All right, so I'm back. Let's answer the question, how can variances be used to understand something about means? I'll put these two graphics up. You've really seen the first one, but the second one's a little bit modified for the following reasons. The first one says, if you look at the first one, I think you can see that there's more variation associated with the treatment, sometimes called the factor variance, right? The variance between. You can see that the means vary a little bit more than there is variance within each group. So in this particular case, s squared b is greater than s squared w. Right? That's what I'm trying to get across there. And if that's the case, then f, which is equal to s squared b all over s squared w, the variance between divided by the variance within, is a number that's greater than 1. So again, that's the test statistic. What we're going to do is plot that on what's called an F distribution, and there's plenty of material in your text on the properties of the S distribution. It looks a little bit like a chi-squared distribution. And if this is indeed a large number, much bigger than 1, if I plot that out here, then the p-value is going to be small. And you have to run through the problem, but if the p-value is small, in particular if it's smaller than the level of significance, then it's likely that you're going to reject the null. So here's a case where the between variance is larger than the within. And how is that characterized? Well, there's a fair amount of difference between the means. In that case, you're going to reject the null. Remember that the null was that all of the means are the same. You're going to reject that and say, no, they're not. There's some difference. That's as distinguished from the second case. In the second case, note that these two variances, the between variance and the within variance, are about the same. There's not very much difference between the means. There's not a lot of variance, substantial variance. They're about the same value, in which case f is a number about equal to 1. So now when I plot, what I find is that value is way up here. The p-value is large. And if that's the case, you probably fail to reject. And again, you can kind of see that while these ratios lead you through it, here's a case where the means are close as opposed to this. Maintain the null hypothesis, say goodbye to the null hypothesis, and it's as simple as that. The issue with ANOVA is calculating this F statistic. Fairly simple thing to do when the size of each of the groups are the same. A little more difficult to do when they're not. Simple to do when you're given data and you're holding your calculator in your hand. Okay, I'm going to come back with one more video and I'm going to run through one of these hand calculations for the case that n is the same, and then we'll move on out of the lectures into the mastery problem sections. All right, very good.